Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together.
This time, it will be the 7th and final time in smart remote control production. We will make it possible to operate home appliances from an outdoor smartphone, and use AI speakers to operate home appliances by voice. We will use an external service for the cloud part, but basically we would like to realize it in a way that can be used free of charge. I will check from the table of contents. Here is the table of contents. First, from the overview, we will understand beebotte and MQTT, and then we will do programming that uses the cloud. Add the library and perform each programming to complete the smart remote control. Next, set up beebotte, connect the smart remote control to the cloud, and check the operation. Finally, I would like to use IF to realize AI speaker cooperation. Move on. This electronic work has become a series that eventually produces a smart remote control, and has been distributed in a total of 7 videos. This is the 7th time and the last of this series. In the previous 6th installment, we realized and completed home appliance operation with a smartphone at home. We will add functions to the finished product and work on it to the final finished product. This time, it is the implementation of the part related to the cloud, and in the operation check, we will realize home appliance operation from the outside and AI speaker cooperation. Move on. This time, we will understand the system configuration to be realized. For use from the internet, we will use beebotte. Set up beebotte and connect MQTT from the smart remote controller to be produced. Using that MQTT, we will access from a smartphone on the internet with HTTP and realize home appliance operation. First of all, I would like you to understand that you are accessing from the outside via beebotte. I would like to deepen my understanding while performing specific settings and operation checks. Let's move on. As for beebotte, as shown in this figure, REST API, that is, HTTP access, WebSocket, MQTT, etc. connection is possible. In addition, since HTTP and MQTT data are exchanged mutually, data communication between different protocols is also possible. Although it is a fee, it is possible to exchange 50,000 messages a day even if it is free. We calculated the amount of messages consumed just by connecting, but the MQTT library used this time sends and receives a keep alive signal once every 15 seconds. That's about 12,000 messages per day. Therefore, I think that 50,000 will be sufficient. Move on. The MQTT used this time is a simple and lightweight protocol developed for terminals such as IoT to communicate with each other in the cloud. Since it has few functions and operates lightly, the consumption of CPU and memory can be kept small. Therefore, it can be said that it is suitable for use in IoT devices. However, it is not suitable for communicating large data such as images, so it is used for sending small information. Next, the reason for implementing MQTT this time is that it is not possible to directly access the terminal inside the house from the outside. A private IP address, which can only be used inside the home, is assigned to the home terminal. Access from home to the outside, that is, to the internet, is realized by the home router converting to a global IP address. For this reason, by constantly performing MQTT communication from the IoT terminal in the house to beebotte and connecting it, it is possible to access from the outside using that communication. This is another video on the Hobby IT channel, but IP address and communication mechanism introduces internet communication in detail, so please refer to it. Move on. We will add libraries to use MQTT. As shown here, first, start the library manager of Arduino IDE. Then find additional libraries by searching as shown here in the search window. Once found, select the version and run the installation. Install the 2 libraries like here. As a precaution, regarding Arduino JSON, please set the version to the latest in the 5th generation. The latest is 6's, but it will cause an error, so please do not use it. Move on. It becomes the file structure of the program. Except for outdoor in the top HTML file, the file structure will be the same as the one created in part 6. Since the file itself does not increase, the configuration is the same, but we will add the MQTT function with the Arduino program. In addition, it is assumed that the HTML file added this time will be saved as a local file on the smartphone and used by opening it with a web browser. The ESP32 has nothing to write to or work on. Move on. Regarding the Arduino program, all files of the program used this time can be downloaded from the Hobby IT site, so please refer to them if necessary. This time, we will extract and understand only the functions to be added. As shown here, we will first load the library and make it available. MQTT will be encrypted using the TLS function. Also, in order to communicate data in JSON format, the libraries to be added are these three. Next, we also define the use of TLS on Wi-Fi and the use of MQTT. On line 75 in the setup function, configure settings using the set certificate. I'll check later how to get beebotte certificate. Move on. In the loop function, always check whether the MQTT connection is being performed, and if it is disconnected, perform the connection process. Here is the reconnect function for connection processing. In this function, MQTT connection is made using the token etc. obtained in the beebotte setting. Move on. This is the callback function. It is a function that is processed when a message is received in MQTT. Since the message has been sent, extract the remote control number data to be sent. Next, call the function in the if statement on line 136 to transmit the remote control. When the transmission process is completed, the success or failure is displayed on the serial monitor. Move on. This newly created file will be an HTML file that can be handled by smartphones. I have JavaScript defined in the header of my HTML file. Basically, it will be the same as the content of HTML and JavaScript that you understood in Part 6. However, this time, both HTML and JavaScript are described in the same file without separating files. Also, the JavaScript part needs to be set, so please understand it. As you can see here, there is a setting at the beginning of JavaScript. Configure the tokens and channels obtained from beebotte here. If you want to use it, be sure to set it and save it before using it. As for the processing, it first determines whether processing is in progress, and if it is not in processing, it executes the HTML request to beebotte. Finally, if there is a response from beebotte, it will display success or failure on the screen. Next, I would like to set up beebotte itself. We will set up beebotte, so access the site. Search from Google and open the site. Log into your account. If you do not have an account, please create one before logging in. No credit card registration is required. An email will be sent to the registered address, so you just need to confirm it. After logging in, first, click Create New. You will be asked to register a channel name, so this time I chose the Hobby IT channel. This time, the description is entered like this. Then enter the resource name. In this example, I entered Resource 1. Now that you have completed the input, click Create Channel. Configuration is now complete. It's very easy. There is a list of channels created here, so we will acquire tokens. Click on the channel you created and you will see your token. This time, we will rewrite the Arduino program using the set channel name and resource name, and the acquired token, so please save them. Next, get the certificate. Please access the beebotte certificate acquisition URL in the summary column or Hobby IT site with a web browser and download the file. The downloaded file will be changed to the format set for Arduino, so please open it with a text editor. After opening it with a text editor, change the beginning and the end of the line with replace all like this. Make a copy when you are done making changes. We will set it up on the Arduino. This is the config file of Arduino IDE. I'm going to change what I just copied here. This certificate data is updated periodically, so please change it if you cannot connect. Pasting is complete. Next, set the values obtained earlier for the channel name and token. Also, although it is not shown in this video, change the Wi-Fi and IP address settings according to the connection environment. Save the changes when done. As a little reference, if the certificate set this time is troublesome, you can skip the process. If you skip it, the correctness of the URL and server will not be proved, but the data will be encrypted, so I think you can judge it. This channel has also skipped the certificate check process in software that uses Google API before. As a skip example, I will post a link in the overview column. As for how to skip it, you can skip it by executing set insecure in the setup function. No configuration of the certificate itself is required. I have confirmed that there is no problem connecting to beebotte, so it is possible to skip it. At this point, all programming and settings are complete. Next, we will actually make an MQTT connection to beebotte and check the operation. First, complete writing the program to ESP32. You need to upload data folder and write Arduino program. If you are unsure, please refer to part 5 for uploading the data folder and part 2 for writing the program. When you write the program and ESP32 starts up, it will be displayed on the serial monitor like this. When the connection is completed with MQTT, it will be displayed as connect like this. In this state, we will check the operation. As shown in this figure, we will control the smart remote control from the computer via beebotte. Use the curl command that makes an HTTP request. Modify this command to the value obtained by beebotte and the remote control number you want to operate. You can operate home appliances by executing this command in the Windows command prompt. Now let's actually do it. Start Windows command prompt. This time, the remote control number is set to 0. Computers start from 0, so subtract 1 from the remote control number displayed on your web browser. Therefore, setting 0 means operating the first remote control. Hit return like this and it will run. First, make sure that true is displayed here. Also, make sure that home appliances can be operated. If the home appliance can be operated, the confirmation is completed. If an error is displayed, it is necessary to take action according to the content of the error. If there are no problems up to this point, the next step is to operate from an outdoor smartphone. This outdoor HTML file has already been changed with beebotte settings. I have already saved the files in the GoogleDrive folder, and I am using the GoogleDrive app on my smartphone to check the files. Then open this file in your app. Since it will open in a web browser, I will use Chrome this time. Save it in your bookmarks for convenient reopening. Now you can open it from the bookmark next time. When you open the file, it will be displayed like this, so you can operate home appliances by clicking the button. Press the button and check the operation. This can be used both indoors and outdoors, but please note that this program cannot display the button names like the 6th indoor use. It means that you need to remember the number and the home appliance. With the above, the smartphone operation from outside is completed, and the next step is to link with the AI speaker. I would like to understand IFT. IF stands for if this then that, which means if you do this, do that. It is a mechanism to provide cooperation of services on the internet. For example, when Gmail arrives, it is possible to link multiple services, such as posting to Instagram. You can use it for free, but I think you can have up to 3 connections called applets. However, IFT has changed many services so far, so please check the site from time to time. Now, let's actually use it to deepen our understanding. First, enable IFT to use AI speaker linkage. This time, we will use Google as an AI speaker. It seems that Google Assistant and IFT can only be linked from the smartphone application, so start the smartphone application Google Home. It used to be possible, so it seems that the specifications have been changed from time to time. Google and IFT already have accounts, so you need to create them if they haven't been created yet. Select Integrate with Google from the settings of the Google Home app. Services that can be linked will be displayed, so enter IFT in the search window and select IFT. You will be asked to log into IFT, so log in. Coordination is done automatically. Finally, I got an error like this, but IFT was able to proceed without any problems, so I didn't respond to this error. Move on. I will set up IFT on my computer. Log into the IFT site and click the Create button in the upper right. Since there is an Add button in IFT, click it. You will be prompted for a service to trigger, so enter Google and search. Google Assistant will be displayed, so click that icon. Please click the icon on the left as it will be displayed as shown here. Next, enter the word that you want to voice control. This time it is called Turn on the Light. Once entered, create your trigger. Next, there is an Add button and then that, so click it. Enter Web in the search window and search for the action service. Click here for webhooks. If you see this, click the icon on the left. If you are using the service for the first time, you will be asked to connect, so please click Connect. The URL to access will be the same as the content used when checking the operation of beebotte. Copy and paste the URL part. Then select the method post. Select JSON as the content type. Finally, in body, enter the remote control number you want to control in JSON format like this. Since the number 0 is entered this time, the remote control number 1 will be controlled. Once entered, press the Create button to proceed. Click Continue on this screen. Click Finish on this screen as well. This completes the settings. With this, AI speaker cooperation is possible. I performed voice operation with an AI speaker, but I was able to confirm the control without any problems. Voice operation was set in English as turn on the light, but it was also controllable in Japanese. It seems that Google has figured it out for you. Also, like this time, voice operation is performed via IFTTT, so it may take about 10 seconds, so the response may feel a little slow. This completes the production and operation check of the smart remote control. This series will also end with the 7th installment.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.